Sun meri baat, it's her choice. But you don't have a choice, you have to learn this. So welcome to part 2. Now we're gonna see where pipelining goes south. We are gonna pull him down, down. But when does pipelining go south? When conditional branches comes to distract it. Everything is not a fairy tale. Pipelining is not cheat code. So when conditional branches comes, it makes it perplexed. Conditional branches says welcome back to reality, while pipelining goes like straight the same black, everything is black and white, no nuance thing, same old classic way. But conditional branches diverts it, then it confuses, then returns, then and wastes time and reduces efficiency. So when we go for execution unit, in it is confined or embedded in the on the microprocessor chip, so it cannot interact with the input output processor, but it has ALU, so it performs operations, execute instruction, and decodes the instruction. So control section decodes the instruction and sends control signals like what to do with the instruction we got, how to operate it. Then general purpose registers comes. That was segment register before in BIU. So general purpose registers are 4 types, like AX register, BX register, CX register, DX register. They are all 16 bits, but they are a double word, I guess. So no, it is a word. 32 bits is double word, 16 bits is word, 8 bits are byte, and 4 bits are nibble. So to divide the 16 bits into two memory segmentation, you will learn it later, to show it like two instruction can go simultaneously. To make 16 bytes divide into two 8 bit structure, to divide the memory space, we can make it AX into H and AL, like AL is lower bits, H is higher bits. So A is accumulator, like it stores operands in for multiplication and division. BX has indirect addressing mode. It has memory address. Like memory address, we take out in indirect addressing mode. We take out effective address to take out operands to operate. And CX is count register, like in loop and shift rotate. It stores the count, like in shift there are smaller counts, so CL it stores, and loop has bigger count numbers, so it stores in CX. The count is how many times a loop has to repeat operation, so that stores there. CX is count register, DX is it is an data register, so it is accumulator when 32 bits are needed, like it adds the 16 bit. Then ALU operates every arithmetic and logic operations. Operand stores carry. Flags are a status of operations. Then there is stack point.